So remember I had this code panel and also the timeline panel.
Huh.
And now you can also like skip around in the timeline. You can click on the a place in the timeline. It'll jump to there. You can
Okay.
also use the arrows. And I added this view menu that can let you like if your panel got hidden by another panel, then
Uh-huh.
you can say bring it to the top. And
Uh,
and also if you close a panel, then you can always bring it back. So,
okay.
yeah.
Will there be like auto arrangement? It's like putting it in the right place so that it won't like overlap with each other.
Yes, I plan to do that at some point. Yes.
Okay.
Yep. Yeah. Yes. That should definitely be there. Uh, but there's other fish to fry for now. Um, so and then other than that, the one thing I actually spent a lot of time on is actually the C code program. Oh, not the C code program. Oh, you know the C code program, which is for like displaying the timeline on the console,
Hmm.
like that.
Okay.
Um, let's do this Fibonacci program actually. Okay. so okay, that's a Fibonacci program that had to calculate a big number probably. I don't know how big. Oh, I can. There it is. Of 18, so it's pretty big. Um, I made another one called C calls, which gives you oh, which gives you the summary in terms of function calls. So this is more summarized version of that,
Okay.
where well, that's taking a while. Where did well, maybe I should just do a smaller one. Mm. And I also had to spend a bit of time optimizing it because it was really slow initially, and now it's only somewhat slow. Okay, so you get this call graph, which
Oh,
basically I stole from Bill Lewis's ODB, Omniscient Debugger.
okay.
He also has a panel in his Java-based UI that is a tree like this. Yeah, and I call this the outline of all the calls, and it'll show you the input parameters and the output of every call. So it's just a very nice summary of what happened in your program in terms of function calls.
Oh,
And
interesting.
yeah, so I
This
think
will be nice for like more like a functional programming approach. Like if all your
mhm.
program is mutating stuff, then this won't help.
Yep, that's true. That's kind of true.
Yeah.
Yeah, I agree. Like if you only have one function call in the whole program, and
Yeah.
then the program is just doing a lot of loops and
Yeah.
stuff, then this won't show you anything at all. Um, but yeah, but I think can this I think would be really nice for teaching algorithms actually. Um, I've actually been planning for a talk with Insighten on dynamic programming, and
Oh, no.
one of there's two ways to do dynamic programming. One of them is with recursion, but which you can use this, and you can use this graph to show why this algorithm is very inefficient. There's a MIT talk that that explains dynamic programming in terms of the Fibonacci sequence at this also, because I think it's a good example to show, because Fibonacci sequence gets taught so many times that people probably already know it, and so you can kind of go faster because you can probably in that MIT course, that guy said, hey, and this algorithm is very inefficient because, and in order to explain why it's inefficient, he had to use these math proofs and these theorems that they established earlier in the class, and use the theorem to show that because there's recursion, the recursion is done this way, therefore the program has to take this long, related to the size of the input, and therefore it's an inefficient algorithm. But I think if I have this tool, all I have to do is, first of all, show them this guy is identical to this guy. Why are we redoing that calculation? And not only that, that guy, and that guy. Those are identical. Why are we? Oh, that happened yet again. Like, that's ridiculous. And also, like, this. Like, we're just doing a lot of repeated work, so we don't need to do that. And you can very easily show that here.
Okay. So why it's called dynamic programming? While what you're doing is just you're basically recording what it has been done before and just use it.
Don't worry about the name. The MIT guy actually explained why it's called dynamic programming. Basically, they wanted a name that sounds like it's not math. Because that research center, they didn't like people working on math or something. I don't know. They just, it was not a good name, and they purposefully made it not a good name. So the name doesn't really matter. But basically, like, once you use the caching, then this happens, right? And that's an extremely good illustration of the point of what it is, and essentially is recursion with caching, or recursion with memoization is what they call it. There's another way, there's a bottom-up way to do it, but whatever. I'm not, that's not the point. We don't have to get into it. My point is this, I think this is a really good tool for teaching algorithms. So I plan to use it for that. And like, that's one of the goals of this project. I'm happy to say the debugger has been holding up well, even though not every bug is easy to solve yet. It still takes concentration to navigate through the code to the place where the problem is. But at least it's straightforward. Like, it's somewhat, it requires you to concentrate, and is a little bit tedious to drill into the code, navigate, go either like step over or step inside or whatever, to find the code. But I think with the features like searching through the database, and an easy feature would just be switching to another source file. That feature doesn't exist right now. Like, if I can just pick which source file I want to go to, and then click on one of the lines to jump to that line, that would already help a lot with the navigation. But also the object timeline thing would really help, as in, if you see that object having a weird value, it just go back in time to last time it was modified, or maybe go back to before it that had that value. I know that's very doable. I just need to do it.
Okay. Would it be like a separate panel for that one?
Probably separate panel. Yeah. So we'll see. We'll see what happens. Okay. I'm basically searching for the ideal debugging experience by trial and error right now. Probably, I was thinking at one point when I think this is ready, I might go to university and ask people to learn it, and then I'll test them, like do an experiment on the people, like have a control group and an experimental group, and people who debug using their usual way versus people who have learned to use this debugger.
Yeah, I think it would be cool if the university can fund you. That would be nice, and then like you can publish a paper about that.
Yeah. The problem is I won't get paid that much at all. It will be a very, very severe pay cut for what I'm used to. If you are established as a researcher or you're really good at getting funding, you can get paid pretty well if you're good at writing grant proposals.
And you can get the student to work for you. like having like research assistant, that kind of stuff.
Sure, yeah, that's possible. I have talked to my former professor. He asked me to get a PhD.